total the what? Potential difference right inside the circuit and the potential difference outside the circuit, that is the external region of the circuit. Both summation will give you what? EMF. That's the electromotive force. While potential difference is now talking about two ends of a wire. This is the definition. The definition says it is the potential difference. The potential difference between any 2 points in the what? Circuit is the work done when one coulomb of charge moves from one point to another. You understand? One coulomb of charge moves from point A to point B. You get? So from there you get your what? Potential difference. Now if you proceed, let's now see the relationship between potential difference and your EMF. Now we relate it with this formula. Remember we said EMF, which is your big E. Are you seeing it? Is the sum total of, now you have your I big R. You understand? This represents the what? Resistance are the what? External circuits. If I say external, I'm talking about resistances that are being formed outside the cell of the battery. Now, we now say plus your I small r. This is your resistance. We call it what? Internal resistance. So from here now, I can have my E, which is EMF, equals to what? IR plus I small r. So from there, your EMF becomes I into R plus small r. From there, your I becomes EMF over R plus what? Your small r. This is the formula that is linking both current, EMF, and the two resistances. So you can see now EMF is the work done in moving a unit of positive charge through their external circuit and inside the cell. Hope you are getting it down. I've just defined what your potential difference is. It is the what? It is the work done in moving what? A unit charge from one point to another. So that has settled the differences between EMF and your potential difference. Now let's proceed to another very good subtopic, and what we call resistivity. Different materials have different electrical conducting powers. Now the ability of material to oppose the flow of electricity is what we call resistance. It's very simple. If I have my material here now, let's assume this is a rod. You get? Now, boy A, the first boy here is holding the rod. The second boy here is holding the rod. Now, mind you, this is a rod. What is a rod? Metallic structure. So, because it is metallic structure, it is what? It is a conductor. What is a conductor? Any material that allows the flow of what? Heat and what? Electric charge. You understand now? So, if this rod will be a conductor, now, the resistivity of this rod, if I say, okay, what is the resistance of this rod? It is the ability of this rod to restrict. You get? I say, what is resistance in terms of this rod now? It is the ability of this rod to resist flow of what? Electric charge. You understand? Across its terminal. So that ability to resist is what we call what? Resistance. Hope you got this analogy now. If I say, okay, what is resistance? Resistance is the ability. You understand? It's the enablement of what? Of a conducting material to resist easily, freely, the flow of what? Electric charge across it. That's just the real definition of resistance. Now when it comes to resistivity, resistivity is denoted by rho. That resistivity rho equals to, let's go. For resistivity now of the material is the ratio of the magnitude of what? Electric field E and the current what? Density. That is E all over what? Your density. Let's assume this is our density. You get? Now, this could be the value of, the formula for your resistivity. But there's another fundamental one. We have your AR over what? L. I'm going to break this down. Now, if we have resistivity to be AR, what's your A? Your A is what we call your cross-sectional area. Now, let me analyze what is meant by cross-sectional area. Look, if I'm to place the surface of my hand on each other, and I'm supposed to grip them together. Now, the surface of the surface of the hand, the plan view of this hand that actually is being placed on the second. Now, that particular forehand, if I have two flat plates, I think you will understand it better. Now, these two flat plates are meant to what? Collapse. Are meant to what? Be joined together. Now, this particular region is what we call the cross-sectional area. You know, if I'm to make it face the board now or face outward, it's going to look like this, a circle. So this circle from this particular structure is what we call cross-sectional area. So the cross-sectional area of this body now will be the area of this structure. Of course, this is what we call a circle. What's the area of a circle? By r squared. What we are getting is now, that's what we mean by cross-sectional area. Now, after that, we have what we call resistance. So multiplication of cross-sectional area and resistance over what? The length of material, this L, is the length of that material. Will give you what we call resistivity of that material. You understand? Now, it has an SI unit of what we call Siemens per second. Siemens per what? Per second. That is SI unit for what? For resistivity. Now, let's proceed. Now, we're looking at this particular question. A wire of length 0.5 centimeter has a resistance of 2.5 ohms. Now, I told you the other time, ohm is the what? SI unit for resistance. Calculate the resistance of the material, which is made up of two conducting material. Now, if this is the length, this is the L, right? Now, we are told to what? Calculate the resistivity of that material. Or you can also calculate what we call conductivity. Let me just strip it in here. Conductivity is the inverse of what? Resistivity. So if you are calculating resistivity, now that's your ohm, AR, all over L. Now your A will be gotten from your radius. Let's assume you are given a radius of 5 centimeter. Now with 5 centimeter, you can easily calculate your A, which is area of what? The square being used. If you look at that material, this is a what? A rod or a wire. If your wire is as long as this, you check the surface of that wire is cylindrical in shape. So definitely, the cross-sectional area of the wire is what? A circle. So we'll be taking a look at pi r squared. You understand? So from here, you substitute in your 5. That will be A equals pi r all squared. That will give you your what? 25 pi centimeter or meter squared. So this is your area. Your resistance is given. We are using this formula. Your length is given. Just substitute all in, then you'll be able to have your rho equals area is 25 pi. Of course, you know the unit of your pi. 25 pi times the resistance, which is what? 2.5, all over the length, which is what? 0.5. So by the time you compute this, you'll be able to obtain the resistivity, which is measured in what? Siemens per what? Seconds. So you can see it's as simple as ABC. So you need to develop yourself more on so many questions.